finally, we're on to restitution and momentum in question 7, the last question in this exam. So what do? Let's read through the question and then add the information to a nice little diagram. So we're talking about a before and after situation. So let's label before, after. We've got particles P and Q of mass 2m and 3m, and obviously the particles won't change their names or masses afterwards. We know that the initial speed of P in this direction is going to be 3u, and the initial speed of Q is going to be, well, it's travelling in the opposite direction, so I know that its value is going to be minus u. And afterwards, I know that P changes direction, so let's assume that it has velocity Vp, which is a positive value, but because it's going in the opposite direction, I need to make that negative, just like I did with the u in the first part. And this one here is going to be Vq. I don't know anything about that currently. We need to show about the speed of Q immediately after the collision. Now, in order to do that, there are always two processes that we go through. The first is momentum based, and that's to say that 2m multiplied by 3u plus 3m multiplied by minus u must be equal to 2m multiplied by minus vp plus 3m multiplied by minus vq multiplied by vq. Dividing through by m and tidying up the left hand side, I'm going to have 6u take away 3u, which is 3u. Dividing through by m, as we said, this gives us minus 2vp plus 3vq. Now let's think restitution, where we know that the coefficient of restitution is going to be the speed of separation, which is vq minus vp, divided by the speed of approach, which is 3u minus u, and that's to say that 4ue is equal to vq plus vp. We wanted to find an expression for the speed of q, so we're going to use both of these parts now and form some simultaneous equations. So we had 3u equals minus 2vp plus 3vq, and in order to make the p's equivalent in both equations, let's multiply by 2, so that would give me 8ue is equal to 2vp plus 2vq. At this point, I can add my two equations together to eliminate the v value, so that gives me 8ue plus 3u is equal to 5vq, and dividing 3 by 5 and factorising the u at the same time, I've got u over 5 of 8e plus 3 as my value for vq, which is exactly what the question had asked for. The second part of this question, I want to find a range of possible values for e. To do this, I need to think about vp, and the reason that I need to think about vp is because I know it has changed direction, as I've signified by this negative symbol here. So I know that the actual value of v must be greater than 0. So I know that vp must be greater than 0. How do I calculate vp? Well, we had an equation, our restitution equation, that's going to allow me to do that. And if I rearrange my restitution equation, I know that vp would be equal to 4ue minus vq. And as we've said, vp must be greater than 0. Now we can use our known fact, so we've got 4ue minus the vq, which was u on 5 lots of 8e plus 3, which has to be greater than 0. Multiply through by 5, and I've got 20ue minus 8ue plus minus 3u, which is going to be greater than 0, which tells me that 12EU has to be greater than 3u, and dividing through by 12u says that e must be greater than a quarter. Now I also know that e has an upper bound because it can never be greater than 1. So here's my final inequality to say that e sits somewhere between a quarter and 1. In the final part of this question, I'm thinking about kinetic energy. It's saying that the total kinetic energy before is going to be given by T, and the total kinetic energy afterwards is given by KT. So whatever the energy of the system before, that being T, to find the kinetic energy after, I just need to multiply that value by K. Or that is to say that to find the kinetic energy after, I just need to multiply K by the kinetic energy before. So the after is going to be equal to K times by before. In order to calculate kinetic energy, we know we need to talk about velocity. And let's go through and find the velocities for the v, q and vp, because we're actually told now that e is half. Where can we pick those up from? Well, we were using earlier the idea that vq was equal to u over 5 lots of 8e plus 3. Now if e is a half, this becomes 4, and 4 plus 3 gives me 7. So in the case where e is a half, vq will be equal to 7u over 5. Now to use my restitution equation, we know that vp will be equal to 4ue minus vq. We've just worked out that vq is 7 over 5u, and we know that e is a half. So in the case where e is a half, we know that vp is going to be 2u subtract 7u over 5, which is going to give me 3 over 5u. From this situation, I'm then able to calculate the kinetic energies before and after. We knew that the velocities before were 3u and negative u, and now we know that the velocities after are 3u on 5 and 7u on 5. So we can use that to go about our kinetic energy calculations. So let's do that just down here. So Ke before is going to be a half m. Whoops, what's happened here? A half of m, which is 3m, times by, not 3m, a half of 2m, lots of 3u squared, plus a half of 3m, lots of minus u squared. That's our before, and then for our after, we know that would be a half of 2m, lots of 3u on 5 squared, plus a half of 3m, lots of 7u on 5 squared. And we also had from our previous equation that we knew that the after was going to be equal to k times by the before. What does that give us? Well, some nice cancellation here tells me that 9mu squared plus 3 over 2mu squared is going to be equal to 9 over 25 mu squared plus, what have we got in here, 49 multiplied by 3, 157 over 20, not 25, over 50. 157? No, that's an absolute lie. 147 over 50 mu squared. Now adding those values together, I get my total kinetic energy before as being 21 over 2 mu squared, and my total kinetic energy afterwards as being 165 over 50 mu squared. And as we said, our after is going to be k times our before, so this after is going to be equal to k times the before, which was 21 over 2 mu squared. The mu squareds are going to cancel out, and I've got 165 on 50 divided by 21 on 2, which is equal to my value of k, which I believe comes out to tell me that k is going to be 11 over 35.